Today we're going to talk about law of cosines. The other two cases where we use law of cosines, we mentioned are cases where we use law of sines in the lesson before. Today we're going to take a look at when we use law of cosines. We use law of cosines when we have either all three sides, which are side, 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 given to us, or two sides and the included angle, which is side, angle, side. Now, listed down below are the standard form and the alternate form. These are all variations of the exact same formula, okay? This standard form you want to use when you are, let me get a pen, solving for a side. Notice that it has the sides by themselves over here to the left. Okay, so again, that's for when you're solving for a side. Notice on the next one, the angles are by themselves over on the left. The cosine of the angle is on the left. So we want to use these when we are solving for an angle, which is actually pretty often. Okay, think about what you have. If you have side, 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 that means you already have all three sides and you're only solving for angles. If you have side, angle, side, then you already have two of your sides and you only have to solve for one other side while you have to solve for two angles. So we end up using the ones on the right the most. So just to kind of go over what these mean, it's not so much that you have to memorize every single one of these. I would memorize the pattern. So take a look at when we're solving for a side over here on the left. We have a squared equals b squared plus c squared minus 2bc times cosine of angle A. So notice that we have the other two sides squared and added together. Take a look at the rest of these. For b squared and c squared, we have the other two sides squared and added together. And then we have minus 2 times the other two sides times the cosine of the angle that goes with the side that's listed on the left. Okay, so it's way more about recognizing the pattern and memorizing the pattern than having to memorize a bunch of different formulas. Okay, the same thing goes for the angles. Take a look at how this one is set up. Cosine of angle A, notice that we have the other two corresponding sides squared and added together minus A squared, the side that corresponds to angle A, all over 2BC, 2 times the other two corresponding sides. Notice the same setup in these, okay? Cosine B and C, we have the other two corresponding sides squared and added together minus the side that goes with the angle listed squared all over 2 times the other two corresponding sides. Okay, so again, it's very much more about memorizing the pattern than necessarily memorizing 6 different formulas. Okay, but also notice that we can get this formula by solving for the cosine in the original standard form. Okay, so it's all the same formula, just moved around or solved for different angles or sides depending on what we're trying to find. Okay, I would say that for the most part, people end up in liking using law of cosines better. So it's usually easy to tell whether you're going to use law of cosines. A lot of times people get confused, but I think it's probably easiest to remember your cases for law of cosines first. Either side, 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 or side, angle, side, you're going to use law of cosines. If you have anything else, you got to use law of sines. Okay, let's go through an example using this to see what we're talking about. Okay, so this first example, solve the triangle using law of cosines. Notice that we are given all three sides. Okay, if it helps you, you might want to label which is which. Okay, 16 is across from angle B, so that's maybe, come on, pen. Okay, that is side B. $12 is across from angle A, so that is side A. And 18 is across from angle C, so that is side C. All right, now let's try setting this up to solve. Okay, I'm going to scroll down so we have plenty of room. Let's say we solve, let's just go in order, the order they're listed. Let's say we want to find measure of angle A first. Okay, well, let's look at our formula. cosine of angle A is b squared plus c squared minus a squared all over 2bc. So let's plug in b squared, 16 squared, plus c squared, 18 squared, minus a squared, which is 12 squared, all over 2 times b, which is 16, times c, which is 18. Now, notice that that's what the cosine of angle A is equal to. So in order to solve for angle A, we're going to have to take the inverse cosine. Okay, this is one where it is very easy to make some calculator errors. So please be very careful about that. Let's take a look at what I'm talking about. Let's try to type this in. Here's how I would do it. Type in the top, hit enter. Divided by, type in the bottom, hit enter. And then do second cosine, second answer. Okay, so let's take a look. 16 squared plus 18 squared minus 12 squared. If I could type, there we go. So that's the top. Divided by, now I'm going to put parentheses because we got to do some multiplication. 2 times 16 times 18, close parentheses, hit enter. Okay, now remember, that's what the cosine is equal to. So we want to find the angle that has this cosine, so we want to do the inverse. Second cosine. Now remember, we talked about above the negative symbol, see the little blue letters, A and S, the answer. And we get 40.804. Okay, so 40.804 degrees. Now, you can type that all in at once, but it's a lot of parentheses. Not a lot, but it's extra parentheses. I'm going to go through how to do it all at once, but please be careful about that. I will tell you that personally, I usually don't type it in at once because I just don't want to make a mistake with parentheses. And for me, it's easier to just type it in those 3 steps. But let's take a look. If you really want to try typing it in all at once, inverse cosine. Now let's put parentheses around the top. 16 squared plus 18 squared. Oops, I forgot my plus. Plus 18 squared minus 12 squared. Close parentheses just for the top. Divided by, parentheses for the bottom. 2 times 16. Oops. Helps if you get it in there. 16 times 18. Close parentheses. Now, this is our parentheses closing for the inverse cosine. And we get the same answer. But again, you have to remember to put parentheses around the top and the bottom. Okay, you can definitely do it. But a lot of times I find that people will put too many parentheses or forget a parentheses and it throws your answer off or you get an error. So just be careful about that. Okay. Now let's try to find angle B. Let's set it up. Angle B, cosine of angle B equals a squared plus c squared minus b squared all over 2ac. So let's plug in. A squared would be 12 squared plus c squared would be 18 squared minus b squared would be 16 squared all over 2 times 12 times 18. So let's go over. Again, I'm going to type it in one at a time. 12 squared plus 18 squared minus 16 squared. Hit enter. Divided by parentheses 2 times 12 times 18. Enter. Now that's the cosine, so we hit second cosine for the inverse and hit second negative to get the answer from before. And we get 60.601. Okay, so whoops. 60.601 degrees. Now, I am going to go ahead and use law of cosines to find angle C. You could take both of those from 180, but what I want to do is use law of cosines to see if my answers make sense at the end. I'm going to add them up and see if I get 180. And because we're rounding, it may not be exactly 180. It may be off by like a thousandth or so. But let's see what we get. Let's set this one up. Cosine of angle C should be a squared plus b squared minus c squared all over 2ab. Let's plug in. A is 12, so we have 12 squared plus b squared, so 16 squared, minus c squared, 18 squared, all over 2 times 12 times 16. Let's type that in our calculator. I'm going to start with the top, 12 squared plus 16 squared minus 18 squared divided by 2 times 12 times 16. And now remember that's the cosine, so second cosine, second answer. 78.585. Now, what I want to check really quick, do my answers make sense? Am I right at 180 for those angles? So let's add them up. 40.804 plus 60.601 plus 78.585. And if you take a look, we are at 179.99. So we're pretty darn close. Okay, so we're only off by 100th. So again, you want to be close because we're rounding our answers. It's not going to be exact all of the time. It's not going to be exactly 180, but notice that that's obviously super close. So our answers make sense. So we did this correctly. Okay. Now you could have taken both of those from 180, both of angle A and angle B from 180 to get angle C, which is fine. Okay. You can do that if you're confident in your methods and your answers. A lot of times I just like to go ahead and use law of cosines to make sure that I'm doing this correctly. Plus, it's then easy for me to check. Let me add up all the angles I got. Are they 180? Because that means that I did this correctly. Okay. All right. Now let's take a look. I'm going to see. Let's go back. I'm going to get rid of some of this work so that we can do our next problem. I'll leave our answers for part A, but I'm going to get rid of our work, and then we're going to do part B. Let's take a look at this one. This time we are not given 3 sides. This time we have 2 sides and the included angle. So we have side, angle, side. What? There we go. So side, angle, side. So we're still using law of cosines, but this one's a little bit different because we have a side to solve for this time. Okay. Again, if it helps you, go ahead and label. 10 is across from angle A, so that's going to be side A. 15 is across from angle C, so that's side C. And then, of course, we have angle B is 20 degrees. So for one like this, we can't solve for anything until we have side B. Think about your formula for angle A. It includes the side B in there. So we have to solve for side B first. So this is our first one where we're using that first standard form, which says b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Okay, so let's plug in what we know. A squared is 10, or 10 squared, excuse me. C squared is going to be 15 squared minus 2 times 10 times 15 times the cosine of angle B, which is 20. All right, now notice that this is what b squared is equal to, so we're going to have to take the square root. Okay, so again, there's 2 ways that we can do this. We can either type it all in at once with the square root, or we can do the square root and hit that second answer key again. So let's look at what that would look like. We'll do it both ways. Let's just type it in to begin with. 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of 20. Now remember that's b squared. So we want to take the square root, and then I'm going to hit second negative to get the answer from before. So this should be our value for b. What is that? 6.564. Now, I'll show you how to do it all at once. take our square root, and now we're going to type in everything as we did. This one's pretty easy to do all at once. You don't have to remember any extra parentheses or anything. The one thing I would caution you, I know some people like to use parentheses for multiplying. I would be very careful in this case, because if you put in a lot of extra parentheses, you might be taking the square root of the wrong portion of this. So I would just type it in as I have, using the multiplication key instead of parentheses. So either way, we get 6.564. Now let's take a look. Let's say we want to solve, it doesn't matter which one. Let's say we want to solve for angle A. Okay, so let's set up that. Angle A is equal to B squared, so 6.564 squared, plus C squared, so plus 15 squared, minus A squared, so minus 10 squared, all over 2 times B, which is 6.564, times C, which is 15. Now, let's go over here to our calculator. I'm going to clear it so that we're starting fresh. Let's type this in. Okay, 6.564 squared plus 15 squared minus 10 squared. I'm going to hit enter, divided by parentheses 2 times 6.564 times 15. Enter. Remember, that's the cosine, so I'm going to hit second cosine, second negative to get that answer in there, and that is 31.397 degrees. So now we know that angle A is 31.397 degrees. All right, so we could go ahead and take those from 180. I'm going to go ahead and use the law of cosines so we have more practice with it to solve for angle C, and then we'll see if our answers end up working. Again, because we're rounding a lot and we're depending our answer on a rounded side B, they may be off by a little bit, but we should be close. So let's take a look. Cosine C should be equal to A squared, so 10 squared, plus B squared, so plus 6.564 squared, minus C squared, so minus 15 squared, all over 2 times A, which is 10, times B, which is 6.564. All right, let's go put this in really quick and see what we get. I'm going to clear it again. Okay, 10 squared plus 6.564 squared minus 15 squared. Okay, notice we have a negative. That's fine. Your cosine value can be negative. Okay, divided by 2 times 10 times 6.564. Okay, we still have a negative for the cosine value. That just means we're going to have an obtuse angle, so don't worry about it. Okay, so inverse cosine, second cosine, second negative to get the answer in there, and we get 128.606. All right, so let's take a look. Oh, I forgot my degrees. Now, let's see if this makes sense. Okay, so let's just take a look at our angles. We have 20 degrees. We have 128.606, and we have 31.397. Let's see what we get if we add those up. 180.003, okay, which is pretty darn close to 180. Now, again, because we rounded so much, our answers are off a little bit, but notice how close that is to 180. That's only off by 3/1000th of a point. Okay, 3/1000ths. Okay, so that's pretty darn good. That's one of the reasons why we usually round to the third decimal place, because it's a little bit more accurate when we do that. So make sure that you are rounding to the third decimal place with all of the stuff that you are doing. We're always rounding to the nearest thousandth, so we can be a little bit more accurate with our answers. All right, one other thing I want you guys to take a look at, mixed practice. Okay, should you use law of sines or law of cosines in order to solve? What I would like you guys to do is to take a minute, and I would like you to I would like you to pause the video and decide whether you think you're going to use law of sines or law of cosines to solve these triangles. Okay, I've got a picture out here for reference so you can see where would this be, what would it be, which case do you have. So I want you to pause this and try to figure out which one you would use for all 5 of these. And then once you unpause it, I'm going to go through which one we would use, okay? All right, hopefully you have paused this and taken a minute to try to decide what you would use. For the first one, notice that we have 3 side measures given to us. This is side, side, side. So of course we are going to use law of cosines. For the second one, we have 2 angles and a side. We have angle B, angle C, and side C. So that would be angle, angle, side. So that is law of sines. Let's take a look. Anytime you have 2 angles and a side, you're going to use law of sines. Take a look at number 3. We have 2 sides and an angle. Let's take a look. Side A, side C, and angle B. That's side, angle, side. That's going to be law of cosines. All right, let's take a look at number 4. We have an angle of 15 degrees and 2 sides A and B. Let's see where that would be. Side A, side B, angle C. That's side, angle, side. So that is another law of cosines that you would use to solve this one. Number 5, you have angle A, and side C. Let's think about where that would be. Angle A, and side C. Notice that that is side, side angle. So anytime we have side, side angle, that is law of sines. Okay. Hopefully this has been pretty informative and you feel pretty confident with law of cosines. You're going to do a lot of practice with these. Feel free to go back through the video and rework those problems and make sure that you're good with those calculator properties.